Welcome to my video lecture series in Object-Oriented Programming. This is Professor Janice Raymond Tang from the College of Computing and Engineering. For this video, we will cover the topics about the introduction to Object-Oriented Programming, which is the leading approach to programming nowadays. If you want to be a serious programmer, you should know about OOP because OOP is used nowadays in developing the desktop application and web applications, even game development. Throughout this video, we will discuss the history of OOP, why OOP, procedure-oriented versus object-oriented programming, the basic concepts of OOP, and the benefits of OOP in real world. Let us begin with the history of OOP. This slide shows the software evolution for the past 50 years. Computing is constantly changing our world and environment. In 1950s, machine language exists. The use of machine code language exists. When we say machine code, this is unsophisticated. So when we say unsophisticated, this is simple and even complex or complicated and machine specific. These machine languages uses machine code such as ones and zeros, which the computer only understands. In 1960s, large machines called mainframes are created. The bank account and payroll programs changed the way organizations work and made parts of these organizations much more efficient. High-level languages became common during this time also in the form of assembly languages, and it made programming much simpler because it uses English languages. Unlike the machine code, it only uses ones and zeros. This time, this is considered as higher level language because we use English language as the commands. However, this led to the development of large, complex programs that were difficult to manage and maintain. In 1970s, structured or procedural programming paradigm exists. Structured programming paradigm became the accepted standard for large complex computer programs because it proposed methods to logically structure the programs developed into smaller, more manageable components. So this will structured programming paradigm is the answer to the problems of higher level programming languages in 1960s. However, significant problems still persisted. So number one, understanding the systems we need to create, and number two, changing existing software as user requirements changed. In 1980s, personal computers exist. People started to own their computers and many use word processors for writing their own letters and spreadsheet applications to manage their home accounts. At the same time, modular languages such as Modula 2 and Ada were developed. So Ada is a programming language named after the first known female programmer, which is Ada Augusta, and these languages became the precursor to modern object-oriented languages. So which means without these modular languages, we will not be able to develop OOP. In 1990s, email and the World Wide Web was born. These technologies revolutionized communications, allowing individuals to publish information that could easily be accessed on a global scale. So, the object-oriented paradigm and the component-based software development ideas were developed also during this time. The object-oriented paradigm sees program requirements in the form of components as the building blocks. And from 2000s up to the present, as of this year, OOP is still widely used approach towards programming. The object-oriented paradigm is based on many of the ideas developed over the past 30 years of abstraction, encapsulation, generalization, and polymorphism. So what are these terms that I mentioned? So these terms are said to be the pillars of object-oriented programming, which means so we need to understand these terms and its concepts for us to say that we learned OOP. So when we say abstraction, it hides details at the design level. So abstraction can be achieved in Java using interface and abstract class. So throughout our course, we will use Java as our programming language to learn OOP. So encapsulation hides details at the implementation level, and we can achieve encapsulation in Java using access modifiers like public, private, and protected. So I think you are familiar with these access modifiers because we are using this in making our programs having methods. And inheritance means deriving a class from another class. So when we say inheritance, we are inheriting the properties of a class and methods of a given class. In inheritance, we are defining at least two classes, which will serve as the parent class, the one who will be inherited, and the child class, which is the one who will inherit the properties and methods of the parent class. So polymorphism means creating objects having many forms. Poly means many, and morph means forms. This can be achieved with the help of inheritance. So it is impossible for us to do polymorphism without the use of inheritance. So these are just overview of the pillars of OOP. We will have a separate uh, discussion about each of these terms in a more detail. So it must be noted that software development ideas are still evolving and new agile methods of working are being proposed and tested. So we will now discuss some of the notable persons involved in OOP. Number one is Mr. Ernest R. Tello. So who is Ernest R. Tello? Um, Ernest R. Tello is a well-known writer in the field of artificial intelligence. He already authored books such as Object-Oriented Programming for Windows and Object-Oriented Programming for Artificial Intelligence. He compared the evolution of software technology to the growth of a tree. Like a tree, software evolution has distinct phases, layers of growth. That is according to Ernest R. Tello. These layers were building up one by one over the last 5 decades. So these are the layers of a software technology according to Ernest R. Tello. So starting from the inner layer, that is the ones and zeros, followed by the machine language, which is the improvement of the previous layer, which is 1 and 0, followed by the assembly language, which is also the improvement of the machine language, followed by the procedure-oriented, and the last one, until now, we are using is object-oriented. So in these layers of software technology, each layer is an improvement of the previous one. Okay? And each layer continuously functional in software system, and only the uppermost layer is functional in trees. However, the analogy fails if we consider the life of these layers. In software system, each of the layer continues to be functional, whereas in the case of trees, only the uppermost layer is functional. Another notable person in the field of OOP is Mr. Alan C.K. So he is one of the promoters of the object-oriented paradigm and the principal designer of Smalltalk. So what is Smalltalk? Smalltalk is an object-oriented, dynamically typed, effective programming language. Using this language, all programs were represented as collections of objects communicating with each other via message passing. So Mr. Alan Kay proposed or created this object-oriented programming language named Smalltalk, which sees programs written as a collection of objects. They are communicating through what we call message passing. So later on, I will show you some of the examples of this message passing. So let us now discuss procedure-oriented programming. So this is the common paradigm you use when you are learning basics and the foundation of programming during your programming 1 days. So procedure-oriented programming is derived from structured or structure-oriented programming, which is based upon the concept of calling procedure. That's why it is called procedure. Procedure means functions in our programming, which consists of a series of computational steps to be carried out. So in procedure-oriented programming, the problem is viewed as a sequence of things to be done. such as, for example, reading, calculating, printing, okay, such as example is COBOL, Fortran, and C. These are examples of procedure-oriented programming. The primary focus of procedure-oriented programming is on functions. Just like what you see in the slide, okay? So we defined a class here named my class. We have two methods. One will serve as our the entry point, which is the main method, and our own user-defined method named my method. So the concept again of procedure-oriented is all about functions. Okay. So to illustrate procedure-oriented, so this is its structure. Procedure-oriented programming basically consists of writing a list of instructions for the computer to follow and organizing these instructions into groups known as functions. So as you can see in the figure, you have the main program here at the top. Okay. For example, you create a function 1 followed by function 2 and function 3. Now you can make another function by calling function 1 and function 2. You can make another function from this function 4, example function 6, and using function 4, you can be able to make your own another function named function 7 by calling function 4, function 2, and function 5. So if you will try to imagine, this is very hard to maintain. So that's the reason why object-oriented programming paradigm is created because of these problems. So these are the specific drawbacks of procedure-oriented programming. So number one, functions are less reusable. So it is very difficult to copy a function from one program and reuse in another program because the function is likely to reference the global variables and other functions. Okay, so hindi siya ganun ka-reusable because the only way for you to reuse this function is to copy the code and paste that code into your own new project. So we will not be able to recycle functions just like in OOP. Even though we create another project in OOP, we can recycle the code. In procedure-oriented, for example, you have an existing project, you have functions on your existing project, then you create another project, okay? So for you to be able to reuse the code from project 1, you have to copy exactly the functions and paste it into your another project. So that is not reusability, okay? Not suitable of high-level abstraction for solving real-life problems. For example, C programs uses constructs such as if-else, for loop, array, method, pointer, which are low-level and hard to abstract real problems such as customer relationship management. So, or even example, a computer soccer game. So this is very hard or difficult to develop. So using functions, it is very hard to maintain. Also, example of a big system, a huge system. So it's very hard to maintain if you are using procedure-oriented. And number 3, it separates the data structures or variables and algorithms or functions. It is because we cannot group related variables and functions in a single entity. In OOP, we can group that into a single entity, which is a class or an object. So that is the difference between procedure-oriented and object-oriented. So what are the some of the popular procedure-oriented programming languages? So number 1, we have the Fortran, the Algol, COBOL, Basic, Pascal, and C. So these are some of the procedure-oriented languages which sees programming in the form of functions. Now let us discuss OOP or Object-Oriented Programming. So OOP eliminates some of the drawbacks of conventional programming methods. OOP exists in order to solve the issues and problems of structured or procedural-oriented programming by incorporating the best structured programming features with several powerful new concepts. It is a new way of organizing and developing programs and has nothing to do with any particular language, and it treats data as a critical element in the program development and does not allow it to flow freely around the system. So what is good in OOP is it ties data more closely to the function that operates it and protects it from accidental modification from outside function. And that is possible through the use of encapsulation and abstraction. And that big difference between OOP and procedural programming, OOP is based upon the concept of objects. Objects contain data in the form of attributes and code in the form of methods. So just to give you an example, a real-life example of object orientation. If we consider a human as an object, when we say data or properties of a human, examples are hair color, age, name, address. So those are properties of a human. So everything that will describe a human is considered as data or properties. Now, what about methods or functions of that particular object? So just like us, human, so anything or actions that can be done by human, just like talking, walking, running, those are examples of methods. So that is how OOP works side by side against procedural-oriented programming. So to illustrate you object-oriented programming, okay, so we have here a simple figure, okay. So in this example, we have object A, object B, and object C. So these are what we call classes, okay. So object, okay, it will become an object if we instantiate the class, okay. So later on, you will identify or you will learn more about OOP, but this is just to give you a simple idea. So for every object or a class in OOP, you have to define its data, function, okay, and you have to communicate from one object to another using functions. Okay, so for every object, you have function, and for you to communicate from one object to another object, you need to use the function of a specific object. Okay, so for example, we have human. Again, considering human, everything that describes a human will be written inside the data. Okay, and every actions that can be done with a human will be defined inside a function. So this is what object-oriented programming is. The data of an object can be accessed only by the function associated with that object. However, function of one object can access the function of other objects. Object-oriented programming sees the basic unit as is a class, which encapsulates both the static properties and dynamic operations within a box and specifies the public interface for using these boxes. Since classes are well encapsulated, it is easier to reuse these classes. Okay, so just like my example earlier, for example, we considered student as a class. Some of the data that can be identified which describes a student is name, address, age, and course. For the function, so these are actions that can be done or performed by the student, such as raising hand, speaking, walking, or even running. OOP languages permit higher level of abstraction for solving real-life problems. The OOP languages such as Java, C++, and C# let you think in the problem space and use software objects to represent and abstract entities of the problem space to solve the problem. So why do we need to use OOP? So let us consider a car and its parts. So let us consider a simple example, a real-life example of an object for you to be able to determine why do we need to use OOP. Again, let us consider a car and its parts. A car has almost 30,000 unique parts. A car is assembled from parts and components such as windows, doors, wheels, engine, brakes, and transmission. These components are reusable. Okay? Example, a wheel can be used in many cars. Of course, of the same specifications only. So the idea of this illustration is why we reinvent wheels if we can reuse this wheel with another object of the same specification of this car. So just like in programming, why do we need to rewrite codes if we can reuse this code? So that's the idea of OOP. Okay. Another one example. Okay. I know you are familiar with Super Mario Brothers. Okay, considering a game, so this time a game, we have characters just like Super Mario or Mario and Luigi in Super Mario Brothers game. So why would we define separate program codes for its player controls? So whatever Mario can do and perform in the game can be done also by Luigi. Okay, so we will not be able to make separate code for Luigi. We will just reuse the code from the player controls of Mario for us to be able to perform the same player controls or movement with Luigi. So same with animations. Why will we create separate animations? Okay. Why would we also create a separate collision detection? So these collision detections are the things we need to put in every character of a game to check whether it collides with another object. Let's say, for example, it hits an enemy, it is an hazard, okay? So that is collision detection. Again, in OOP, just like in game development, it is very useful. If we want to make a program, okay, let us consider the use of objects, the concept of objects. So for us to be able to reuse and reuse the code. Again, that is the major purpose of having our OOP for code reusability and recyclability. Another example is this one. Okay, so in the case of game development, let us say for example you created a tennis mobile game a year ago and you decided to make a badminton mobile game. Instead of writing again the codes for player controls, for your badminton mobile game, you will just include the player controls class from your tennis mobile game and enhance the code. So this is to avoid what we call reprogramming, which means in tennis game and badminton game, more or less, player controls are almost the same. Okay, if there are changes, minimal only. Okay, so if you want to make a game, for example, you want to make a badminton game. Okay, so you should only refer to the player controls class of the tennis game. Check if this is 100% applicable. If there are changes, you can modify naman. Okay, instead of copying the code, you will just include the code. Inclusion means not does not mean copying. Inclusion means you are what do you call this? Importing the class on your new project. Only other aspects of the game which are unique will be defined from scratch. Let's say for example, in our figure, okay, tennis game has a different gameplay with badminton game. So since they are different, you can define your new gameplay for the badminton game. But the player controls, if they are almost the same, you can just include them. Same with character models. Character models of tennis games somehow different. Okay, so you should make another character model for the badminton game. Same with levels and maps. So only the unique will be defined, but the common should be included. Okay. Same scenario happens if you create different versions of the game like NBA 2K mobile games. So if you are familiar with NBA or NBA game, even using console or PC and Android or iOS games, every year they are releasing different versions. Okay? Come to think of it, if they are starting from scratch or making the new series or new version of the game from scratch, it will take so much time for them to finish that. So what they do, they created the first version of NBA mobile game as an object-oriented approach, in object-oriented approach, then they are just recycling the code from the previous version. And in the newer version, they are just modifying some of the codes of the previous version. So they are just enhancing. They are not starting from scratch for every release. Otherwise, it will take time for them to develop or finish just to release the new version of the game. So that is what happens in releasing new games. Example nga, if you have different version of a game every year. So as an example in soccer game, okay, come to think of it. For example, you are trying to make a soccer game. So seeing soccer game as a concept, using the concept of objects, you will identify objects such as in a soccer game there is a player or there are players. There is also a ball, a field, referee, audience, weather, and scoreboard. So these are just some of the possible objects that you can identify in a computer soccer game. Now, every object you should define and identify its data and function. Okay, these are data and function of player and ball are different. Okay, so that is the idea of making programs, seeing programs in the form of objects. It is quite difficult to model the game in procedure-oriented languages, but using OOP languages, you can easily model the program accordingly to the real things appear in the soccer games. For example, in player, what are some of the properties of a player? Of course, every player should have name, number, X and Y location in the field, and etc. So what are some of the functions or operations or actions that can be done by the players? We have run, jump, kick the ball, and etc. So those things are just to describe the player. For example, the ball. What are the attributes of the ball? Okay, for example, X, Y, and Z position in the field, the radius, and the weight. So, sir, where is the reusability of the soccer game? So, most importantly, for example, some of these classes such as ball and audience can be reused in another application. For example, in computer basketball game. Okay, same with a soccer ball. Okay, so you can also define the ball of or the basketball having X and Y position in the field, radius, and weight. So instead of creating another class for that ball, why not reuse the class you previously created in a soccer game? So that is how important OOP in creating real-world applications. Compared to procedural, it is impossible. So what are some of the languages available in object orientation? So of course, number one, Java. That will be our programming languages to be used for the entire course. C++, C#, Python, PHP, and JavaScript. So those are some of the object-oriented languages. So let us define what is object-oriented programming. Object-oriented programming is the most recent concept among programming paradigms and still means different things to different people. So what are the features of OOP? Emphasis is on data rather than procedure. Again, I showed you earlier. So what is important in OOP is data rather than procedure. Okay, because in OOP we treat each program in using the concept of objects. Again, programs are divided into objects. Data structures are designed such that they characterize the objects. Functions that operate on the data of an object are tied together in the data structure. Data is hidden and cannot be accessed by external function. Objects may communicate with each other through function. New data and functions can be easily added whenever necessary. It follows bottom-up approach in program design. So when we say bottom-up approach, we started with the specific up to the general. So that is bottom-up approach. That is the opposite of procedural. In procedural, that is top-down approach, starting from general to specific. So let us compare procedure-oriented and object-oriented. So in procedure-oriented programming, program is divided into small parts called functions. Again, I already discussed this earlier. So in procedure-oriented, we always create programs through functions. Function callings only. So it does not have any proper way for hiding data, so it is less secure because in procedure-oriented, we don't have the concept of encapsulation, abstraction. Unlike in the OP, we have that concept. It follows top-down approach. Again, that is from general to specific, the general requirements down to specific. Overloading is not possible. So when we say overloading, the way you create multiple functions of the same name, the way you create another class which inherits a class and creating an overloaded function of that class, it does not have access specifier. So it doesn't, the use of private, public is not necessary in procedure-oriented because you only have one class. Function is more important than data in procedure-oriented. Adding new data and function is not easy, and it is based on unreal world. Again, unreal world because it is impossible or it is very difficult for you to make, for example, a computer soccer game out of procedure-oriented. Okay. What about the OOP? So, OOP is divided into small parts called objects. It provides data hiding. Okay, so it is more secure. So we can use the concept of encapsulation. We can use abstraction. Again, we have a separate discussion for that in more detail. It follows bottom-up approach starting from specific up to the general requirements. Overloading is possible. It has access specifiers. In OOP, it is important that you identify the right access specifier, just like private, protected, and public. Data is more important than function. And adding new data and function is easy in OOP. And it is based on real world because we identify objects as an important requirement in every program. So what are the benefits of OOP in the real world? Since OOP focus on components rather than procedures as compared to procedural programming, it has the following benefits in real world. Number one, ease in design software. So why? Because it leads to more productive software development. Ease in software maintenance, because in object-oriented software, it is easier to understand. Therefore, it is easier to test, debug, and maintain. And of course, the last one, reusable software, because you don't need to keep reinventing the wheels of a car and rewriting the same functions for different situations. You just need to import or include to your new project. In summary, we could say that the object-oriented paradigm is based on many of the ideas developed over the past 30 years of abstraction, encapsulation, generalization, and polymorphism. Object-oriented programming is the most recent concept among programming paradigms, and object-oriented programming treats data more important than functions. So for this lesson's activity, try to identify a real-world object around you and illustrate the object as a class having data or properties, just like my example earlier in a human object, and methods or the function. Use the box with 3 compartments for the name of the class, the properties, and methods, just like what I illustrated earlier again. So use that format. So that's it for now. Thank you for watching and hope you enjoy this video. For inquiries, feel free to post your questions in our group chat. In our next video, we will discuss about classes and objects. Don't forget to visit the links in the references section for more information about this lesson. See you in the next video.